Okay, so we are to determine the tensile force in the cable and the compressive force in the womb. So this is one topic in equilibrium. So at first, we are going to draw the free body diagram of this. Selecting our point of concern in this pin. Okay, so let's say that pin is pin A. So if you're going to draw the free body diagram to be our FBD at pin A, at pin A. So this is our X and Y axis. So what we will have is 600 kilonewton. A compressive force in the boom. Compressive meaning it's a force acting towards a certain point. So if this is our point A, our compressive force will be in that direction, and this will be our C. And a tensile force in the cable, and we denote this as T. And the tensile force is a force that is away from the point. So if this is point A, tensile force of the cable is away, so that would be going there. Our compressive force is going there. So if you will imagine, so the compressive force is acting towards A. So this will be the compressive force, and the tensile force will be away from A. So that will be our X and Y axis in the drawing here. So we all know that the force is force as a line of action. And if we are going to extend this compressive force C, it will be acting along that line. So we can now have a concurrent force. So we will erase this one. Okay, and we represent this as our compressive force C and our tensile force T. So what will be the angle? This one is 30 degrees and that one is 45. So opposite that side is also 45 degrees. So we consider T, C, and the 600 kilonewtons. So in equilibrium, the summation of all the forces along x-axis will be equal to 0, and summation of forces along y-axis is equal to 0. Okay, so we now get this solution. So we have summation of all forces x should be equal to 0, and that would be C cosine 45 minus T cosine 30 is equal to 0. And so C is equal to T cosine, let's set this one. C is equal to T cosine 30 over cosine 45. So if we are also going to get summation of all the forces along y, positive upward forces, so we have T sine 30 plus C sine 45 minus 600 is equal to 0. And substituting this equation 1 to this value here, so we have T sine 30 plus T cosine 30 over cosine 45 sine 45. That would be equal to 600. Transposing the 600 to the right. And so factoring this out, so we have T sine 30 plus cosine 30, and this is sine 45 over cosine. Sine over cosine is a tangent, so we have tangent 45 is equal to 600, and so we get the value of T as 439.23 kilonewton. And this will be the value for the tensile force in the cable. So we can find the compressive force in the boom. We just substitute, we just use this. And so we have T is 439.23 cosine 30 whole over cosine 45, and thus our C is 537.95 kilonewton. And this is the compressive force in the boom.